Welcome to class 11 Physics, Unit 4, Chapter 6, Work, Energy and Power. And today we discuss some questions, some selected questions. And this is class number P49 plus 1 Physics for HSC, CBSE and IC students. Some questions and their answers from chapter Work, Energy and Power. So these questions are one mark questions. One mark question, or you have to answer in one word or in one sentence. Some questions are here. The previous questions we have discussed, and these questions you have to answer in one word or in one sentence. These are the questions. Is frictional force a conservative force? Is frictional force a conservative force? The answers are also given. Answer. No, frictional force is not a conservative force. Frictional force is not a conservative force. So the answers are written after the questions, so you can read them later. I shall read the questions. Define power. Question number 18, what is SI unit of power? Number 19, write dimensions of power. Question number 20, what is the relation between 1 kilowatt and 1 HP? And number 21, define energy. 22, is energy a scalar or a vector? Number 23, do work and energy have same units? Number 24, is electron volt, the EV, a unit of energy or power? Number 25, write relation of EV in joule. Number 20, can a body at rest have kinetic energy, potential energy? That's the question. Question number 27. Write expression for kinetic energy. Question number 28. Write expression for gravitational potential energy. Question number 29. What is expression for potential energy stored in a spring? Question number 30. Name 4 forms of energy. Question number 31. What is the mass energy equivalence relation? All answers you know. If you have any doubt about any question, you see the following answers. Question number 16, no, frictional force is not a conservative force. Number 17, power is defined as the rate of doing work. Number 18, SI unit of power is watt. Number 19, dimensions of power is ml square t raised to minus 3. 1 HP is equal to 0.746 kilowatt, or we can approximate it, which is 0.75 kilowatt. Number 21, energy is the capacity for doing work. Number 22, energy is a scalar quantity. Number 23, work and energy have same units. Number 24, EV is the unit of energy. Number 25, 1 EV is 1.6 into 10 raised to minus 17 joule. No, body at rest cannot have kinetic energy, but it can have potential energy. The question is, question number 26, you see. We go back and see question number 26. Can a body at rest have kinetic energy? Restirula vastuvilu kinetic energy undu. No enna uttaram. Potential energy. Yes, a body at rest can have potential energy. So answer to 26th question is no. Then you have to put a full stop. A body at rest cannot have kinetic energy, but can have potential energy. Number 27, K is half mv square. Number 28, gravitational potential energy U is mgh. Number 29, P of spring, potential energy of spring is half K square or half Kr square. In any form you can write. Question number 30, chemical energy, nuclear and mechanical energy, nuclear energy and heat energy. The 4 forms of energy. Any 4 forms. Chemical energy, mechanical energy, nuclear energy, heat energy, sound energy, light energy, magnetic energy, There are so many forms of energy. Now, next question is true or false statements. Some statements are true and some are false. You have to identify them. State whether the following statements are true or false. True, you can mark as T, and false, you can mark as F. A. Power is the capacity of doing work. It is a true or false question. So some statements are true, some others are false. Power is the capacity of doing work. It is not right. It is energy is the capacity for doing work. So see the answer. Answer A, false. Read the question. Energy is the capacity for doing work. It is right. It is true. Then, work done by a body against a friction results in loss of kinetic energy. Work done by a body against a friction. It is right. You can see the answer. It is true. Number C. Work done by a body against a friction results in loss of potential energy. Answer D. Answer to question D. Answer, it is false. The rate of change of linear momentum of a system is directly proportional to sum of the internal force of the system. Number F. Work done in the motion of a body work done in the motion of a body over a closed loop is zero for every force in nature. The answer to F is false. Work done is not zero under frictional force. So the answers of all questions A, B, C, D, E, F are given here. Next comes a few multiple choice questions and the answers are also written here. You see the answers. Two masses of mass 1 gram and 4 gram moving with equal kinetic energy, the ratio of the magnitudes of their momenta is 4 is to 1, 2 is to 1, 1 is to 2, 1 is to 6. Answer is given at the end. Next question, a uniform chain of length L and mass M lying on a smooth table and one end of the length is hanging vertically down over the edge of the table if G is the acceleration due to gravity. If G is the acceleration due to gravity, the work required to pull the hanging part on the table is mgl, mg into L by 3, mg L by 9, mg L by 18. Next question, if G is the acceleration due to gravity on Earth's surface, the gain in the potential energy of an object of mass m raised from surface of Earth to a height equal to radius of Earth is mgr by 2, 2 mgr, mgr, mgr by 4. Next question. A particle of mass 1 kilogram is thrown vertically upwards with a speed of 100 meter per second. After 5 seconds, it explodes into two parts. One part of mass 400 gram comes back with the speed 25 meter per second. The speed of the other first just after explosion is 100 meter per second, 600 meter per second. 100 meter per second upward, 600 meter per second upward, 100 meter per second downward, 300 meter per second upward. Next question. The potential energy function of a particle of mass is given by U is equal half k square 4x less than 0 and U is equal to 0 4x greater than or equal to 0. If the total energy is E, then its speed at x is root of 2E by k. K is 0, root of 2E by k. See, root of E by k, root of E by 2. Next question. A body falling from a height of 10 meter rebounds from the floor if it loses 20% of the energy in the impact. How high will it rebound? A body falling from a height of 10 meter. ഒരു വസ്തു 10 മീറ്റർ ഉയരത്തിൽ നിന്ന് വീഴുകയാണ്. ആ റീബൗണ്ട്സ് ഫ്രം ദി ഫ്ലോറിൽ നിന്ന് അത് തിരിച്ച് മേപ്പോട്ട് പൊങ്ങും. If it loses 20% of energy in the impact, ഇങ്ങനെ വീഴുമ്പോൾ 20% energy ലൂസ് ആവും, നഷ്ടപ്പെടും. How high will it rebound? എത്ര മേപ്പോട്ട് പൊങ്ങും? 10 meter, 8 meter, 12 meter, none of the above. Next question. A machine which is 75% efficient uses 12 joule of energy in lifting up 1 kilogram mass through a certain distance. The mass is then allowed to fall through that distance. The velocity of the ball at the end of its fall is root 24 meter per second, root 32 meter per second, root 18 meter per second, 3 meter per second. Next question. A wound watch has no energy stored in it, heat energy stored in it, electrical energy stored in it, mechanical potential energy stored in it. Number 9. Which one of the following is a form of energy? Pressure, momentum, light, power. Next question. A uniform force of 4 Newton acts on a body of mass 80 kilogram for a distance of 2.0 meter. The kinetic energy acquired by the body is 4 into 2 joule, 4 into 8 into 2 joule. Next is 3 by 2. 3 by 2, it is 1 by 2. 1 by 2 into 4 into 2 joule, 8 into 9.8 into 2 joule. The answers are given here. Answer to all the above questions are given here. You see the answers. 1C, 2D, 3A, 4A, 5B, 6B, 7C, 8D, 9C, and 10A. You check the answer and try to calculate. If any question needs a solution, you can ask, put a comment. That is all with this 49th lecture. We continue our class. Thank you very much.